Okay, having a wee look at 2015, and we have two questions in this paper. So questions 5 and question 7. So 5a, y equals 7x minus root x over 3 plus 1 over 4x. So first of all, write it properly. So 7x minus a third x to the half plus a quarter x to the minus 1. Differentiating that, x disappears, power goes to front, subtract 1, power goes to front, subtract 1. Part B, you're looking for the curve sketch of this and put on all relevant points. So it crosses the y-axis when x equals 0. So if you put x equals 0 into that, you get y to be 0. So that's the first relevant point. It crosses the x-axis when y equals 0. So put y equals 0. So it's x cubed minus x squared. Factorise out your x squared. Put each bit equal to 0. So x is 0, y is 0, x is 1, y is 0. So that's your next relevant point. Now you need the turning points. So turning points is when dy by dx equals 0. So let's do dy by dx. Differentiate that, 3x squared minus 2x. Put it equal to 0 and solve. So pull out your x, just factorise it. So you get x equals 0 and you get 3x minus 2 equals 0. So x equals 2/3. Remember these are coordinates, so put them in to find y. So y is 0 minus 0. That's that coordinate. Put in x be 2/3. So 2/3 cubed is 8 over 27 minus 4 over 9, which works out to give you minus 4 over 27. So that's your second coordinate. Now you must find the nature of these. Here you've got dy by dx. So differentiate it again, 6x minus 2. When x is 0, your second derivative works out to be less than 0, so it's a maximum. And when x equals 2/3, your second derivative is 6 times 2/3, which is 4 minus 2, which is 2, so it's greater than 0, so it's a minimum. I'm pulling all that together in a picture. It crosses at 0, 0, it crosses at 1, 0, maximum turning point at 0, 0, minimum turning point at minus 2/3 minus 4 over 27. So it's just a matter of joining the dots, something like that. And the next one we've got to look at is question 7. In question 7, we've got to work out the volume. So volume is a third the area of the base times the height. Now I need to work out the height. So we need to get rid of the radius. If you look at the question, it's got the volume in terms of h but no r. So you can use Pythagoras' theorem here to work out the radius. So it's 9 squared minus h squared square rooted. So I want the radius squared, so just squaring that. So it's 9 squared minus h squared. So the radius squared is just 81 minus h squared. So volume is a third pi 81 minus h squared times h. Timesing all that out, 81 divided by 3 is 27 pi times h minus a third pi h cubed. Now you've got to find the max min, so it means you're going to differentiate. So dv by dh, differentiating the h, it disappears. Differentiating this power goes to front, so 3 over 3 is 1. Put that equal to 0. And you want to find the h. So 27 pi equals pi h squared. So h equals the square root of 27. And I'm just going to take you through a wee bit of your surds here. Square root of 27 is the square root of 9, square root of 3. So h is 3 root 3. Now you must prove it's a second derivative, or it must prove using your second derivative. So differentiating that disappears. Differentiating this, you get minus 2 pi h. So when h equals 3 root 3, the second derivative is minus 2 pi times that, It's a negative, so it means it's a maximum. Now, it wants it h as well. R as well. So R, if you look up here, R is the square root of 81 minus h squared. So there's h. So if I square it, I just get 27. So R equals the square root of 54. 54 is 9 times 6, so 3 root 6. So the ratio of h to R, there's h to R. Those 3's cancel off, so it's root 3 to root 6. Remember what root 6 is? It is root 3 root 2. So those cancel off, giving you 1 root 2.